ChatGPT can call tools on my local machine. No API bill attached. Let me show you how.
Intelligence, the final frontier. These are the field reports from Project Gepetto, a continuing mission to explore what emerges between human intuition and machine reasoning, and to boldly build what no single intelligence could create alone. Log entry 8. Mission status. Optionality. One capable crew carried the system from architecture into code for most of the journey. As Gepetto grew, that strength revealed its limit. A single provider still determined whether that development chain could continue. A second route is now open. One crew no longer determines whether the journey continues. The longer course leads toward local center of thought and creation, free to call an outside intelligence whenever the mission requires greater reach.
I worked mainly with Claude for a long time, without any real problems. At some point, I realized how much of my working day I was sitting here waiting for Claude to finish. Opus 4.7 in the Windows app could become painfully slow. I could switch to a faster model like Fable 5 and burn through my available usage instead, but that did not remove the bottleneck. And when Claude reached a limit or went down, my workflow went down with it. Nothing was wrong with the individual tools. The weakness was the topology. A larger Gepetto change passes through analysis, concept development, independent review, and architectural checks before it reaches an executor as an approved work package. It is a deliberately controlled chain, and that entire chain still depended on one provider. This is the actual cost structure behind the process. Roughly $8,500 in local AI hardware and $132.60 per month in AI subscriptions. Calculated across 3 years, the complete development center comes to about $369 per month. But much of the local capacity has not yet reached its full usefulness. That is one of the reasons Gepetto exists, to turn hardware I already own into a development system I can actually rely on. I already had ChatGPT and Codex. What they lacked was controlled access to the same local project and the same governed tools. So I connected the ChatGPT Windows app to Gepetto through a Secure MCP and HTTP tunnel. Here is how the connection works. So we have ChatGPT on the left and my Gepetto workbench on the right. I'm asking it to read the backlog file on this machine and discuss with me what the next item should be. ChatGPT decides it's needed tool and fires the call. On the right, Gepetto reports an incoming read session request. Nothing has been read at this point. The call is parked. I approve it. A read session appears on the list. Scoped to the one directory this client is allowed to see, and the tool call completes. One thing needs saying. This app runs unrestricted on the ChatGPT side. So ChatGPT itself won't ask me to confirm a single call. Everything that decides whether a call may return happened on the right half of the screen. Same setup, one more request. This time I'll say no. ChatGPT wants to reread the master file. The session request lands on the right and I reject it. ChatGPT reports that the fresh read was rejected and that its summary is based on the version it read earlier in this conversation. It even names that version and its date. This one I approve on purpose. I'm asking for a file at the top of drive D, deliberately outside the directory this client is rooted in. The session request comes in, I grant it, and the read fails anyway, because my approval and the workspace boundary are two separate checks. A session I grant applies inside the assigned root and nowhere else. A pass outside it gets stopped as a boundary violation, regardless of what I clicked. One thing about the data path. Said plainly, because it should surprise nobody. The execution happened locally, the inference did not, and every approved tool result traveled to OpenAI. That is simply what working with a cloud AI means. Data that enters it ends up with the provider. And assuming anything else would be, with all due respect, a little dim. Which is exactly why my governance sits where it does. It can't undo that trip, so it decides which data makes it in the first place. So let me walk you through the setup in the order the screen actually come, because the order turns out to matter more than the documentation admits. First up, settings, security login. This is where the developer mode lives, and it has to be on before anything else in this video makes sense. OpenAI's documentation listed as available for Pro Plus, Business, Enterprise and Education accounts. Free accounts don't get the toggle, so the cheapest way in is the $20 Plus plan. Under plugins sits my existing app, Gepetto Access, and ChatGPT flags it with a security warning. What the warning states accurately is that I've switched off the manufacturer's governance. Every call runs without a ChatGPT asking first. I did because I have my own, and you watched it work in the opening. To build this from scratch, you close that and use the plus at the top right, which creates a new app. I call this one Local MCP Access as an example. The authentication default is OAuth. I switched it to No Authentication. This is a single-user workspace, and the tunnel doesn't expose my local server publicly. In this mode, ChatGPT sends no separate user identity with its requests, which is sufficient here because Gepetto identifies the connector and applies its own governance. In a shared workspace, I'd use OAuth, so the server could tell individual users apart. And with a direct server URL instead of a tunnel, the endpoint would need proper authentication of its own. ChatGPT reports that I have no tunnels yet and offers to fix that. And the button drops me out of ChatGPT entirely onto the OpenAI developer platform, where I have to log in again. This is a separate account context from the chat product. And that separation will come back when we talk about billing. Creating the tunnel itself is an inspector form. Name, description, create. What you get back is a tunnel ID, and it's worth being precise about what it does. An identifier, not a secret key. The client on the machine will use it to say which tunnel it wants to serve. Top right, the platform offers a tunnel client download, and the link goes straight to a GitHub release on OpenAI's own repository. And don't go looking for this on PyP. This is the Python package called Tunnel Client, and it has nothing to do with OpenAI. Back on the platform, one menu item over. API keys. And yes, this setup needs an API key, which sounds like the exact moment the meter starts running. It is, after all, the smoking gun I mentioned in the opening. So, as a small insurance policy of your own, don't put any billing information on this platform account. You give it a name and a project, and then, instead of the default, you choose Restricted, which opens a long list of permission scopes. Everything in this list stays off, except one block, tunnels, where I can enable read and use. Then create. What comes out is a key that can authenticate the tunnel handshake, and you can do nothing else. It cannot call a model, and in weeks of daily use, it has produced exactly 0 usage entries on this platform's billing pages. The tool calls themselves travel through the ChatGPT product, which the subscription already covers. The platform side of the setup never builds a token. There are 3 files I actually operate this with, and they are short enough to show them on camera. The start file does 3 things. It loads the 2 credentials, the restricted key and the tunnel ID, from a local env file that never enters Git and won't be entering this video either. It writes a timestamp into a log, and it starts the tunnel client with 2 arguments. The first points at a wrapper script that launches my MCP server. And if you look closely at that path, you'll see / on Windows, which is not a style preference. The Go parser inside the tunnel client eats backlashes and as escape characters, and the error you get shows a path with every separator missing, because that's what the parser left of it. The second argument moves the health spot to 8085. The default is 8080, and on this machine that's already taken by my reverse proxy. The status file checks whether the process exists and then prints the last 12 lines of the log, and both halves matter. A running process only proves the exe is alive. Whether the connection to OpenAI actually stands is something the log tells you, in the form of a green started line or a 401. The stop file is a single task kill, and the flag that earns its place is /t, the tree kill. Without it, Windows stops the tunnel client and leaves the Python adapter it spawned behind as an orphan, still holding its pipes and handles. I learned that the slow way, and the comment in the file exists, so I don't learn it twice. The tunnel solved the immediate access problem, but it also changed the structure behind the work. Gepetto is no longer built through one continuous conversation with one model. I define the direction, make the final decisions, and decide what enters the system. Claude carries most of the architectural continuity. ChatGPT now provides a second development path, while Gemini remains outside both teams as an independent counter-perspective. Claude Code and Codex work closer to the repository. They verify the existing state, implement defined changes, run the tests, and return the evidence needed for review. The practical result is a second complete development path. Claude normally works with Claude Code, while ChatGPT works with Codex. Either team can continue when the other provider is unavailable, and each can review the work produced by the other. But those pairings are no longer fixed. Claude can prepare work for Codex, and ChatGPT can direct Claude Code. The models and tools can change while the rules around the work remain stable. Both paths lead into the same repository, documentation, governance, and test environment, and the final decision still remains with me. The same structure also opens the path toward local execution. A cloud model may remain in the architect role, while a local model operating through Gepetto takes over implementation under the same control process. The longer-term goal is a hybrid open thinking and creation lab with a strong local center of gravity, able to reason, experiment, and build without making cloud availability or provider policy a condition for every step. Cloud AI would still have an important place. It could provide an independent review, add reasoning capacity when the local models reach their limits, or take over a complete task when quality, latency, complexity, or the cost of an error makes that the better decision. So, how do you organize AI-assisted development around local and cloud models? Which work stays local? Which parts do you delegate to the cloud? And where have you found the real bottlenecks?